Okay, yeah, I've got 4 problems. These are kind of the conceptual ones. I just wanted to hit these one time with you guys before the test. Make sure this all makes sense. These are important. You're not really showing any work on these, but it's important to understand what these mean. So let H be the composition of f and g. So h of x equals f of g of x, where f and g are differentiable on their domains. If g of 9 equals 8 and g prime of 9 equals negative 4, what else do you need to know to calculate h prime of 9? Well, let's just look at the chain rule here. If this is h of x, what's h prime of x equal to? By the chain rule. F, say it again? F prime of g of x. Times g prime of x. Okay, so then what would you need? So we're trying to evaluate h prime at 9. So that's going to equal f prime of what? Of g of 9. Okay? Times g prime of 9. Well, what do we know here? We know g prime of 9, we know that value is negative 4. We know g of 9 is 8. What is it that we don't know then? Yeah, f prime of 8. Exactly, right? So what this ends up being, this is f prime of g of 9. There's g of 9, right? That's f prime of 8 times g prime of 9 So what are we missing? F prime of 8. That's the other thing we would need to answer this question. Okay, make sense? So that would come from here, f prime of 8. Give me thumbs, does that make sense? Okay? So the derivative of f of g of x equals f prime of x. So the derivative of f of x evaluated where? At g of x, exactly. Evaluated at g of x multiplied by g prime of x evaluated at x. Okay, you get that? Because what did we say before? F prime, the derivative of this composition is f prime of g of x. That's what all this stuff is just saying right here. All that stuff is really just saying f prime of g of x. Okay? When we say evaluated at, that means that's what we're plugging in, right? Okay, give me thumbs. Does that make sense? Okay? Okay, so this is not calculus, right? This is just like, I don't know, pre-calculus, maybe algebra 2. We're just trying to figure out what are the layers of this function so we know how to evaluate it. So the way we're trying to set this up, q of x, what is the outer layer? Which function represents the outer layer? Which function is the outer layer? F of x, right? Everybody see that? Because f's the outside, that's the outermost function is f. Next layer would be g of x, right? Be the next layer. And then the inside layer would be h of x. So what's useful to do on problems like this, when you have like a shorthand notation for a trig function, is to not write it that way. Write it explicitly as layers. How should I rewrite this then? What does this mean? So it means that whole cotangent function taken to the fourth, right? Okay. Okay, so the outermost layer is the power, right? It's a power function on the outside. What's the next layer? Yeah, cotangent of something. And if I look inside the cotangent, what do I get? Okay, so then what is the outer layer? H of x would be what? The outermost layer is hand to the fourth, isn't it? Right, so f of hand is hand to the fourth. Well, what is f of x then? X to the fourth. There you go. Okay. The next layer you told me was cotangent, right? So the middle layer would be g of hand is cotangent of hand. So what's g of x? Cotangent x. And then the inside layer is just x to the ninth plus 7. Okay? Does that make sense? Give me thumbs on that. How are we doing? Okay? Do you see why those are, like, how these are x's here, why we're inputting x's? Because the x's are just showing us what are we doing with inputs. F of x would just be x to the fourth, right? F of something bigger would just be that bigger thing to the fourth. Okay? And then finally, last one. These guys, right? So if I want to calculate h prime of 1, and again, here's h of x. H is f of g of x. So by the chain rule, what is h prime of 1 going to equal? Like, differentiate that composition using the chain rule. What is that? What's the derivative of f of g of x by the chain rule? F prime of g of x times, okay, so h prime of 1 would just be f prime of what then? G of 1, right? F prime of g of 1 times g prime of 1, right? If h prime of x is f prime of g of x times g of x, then h prime of 1 is f prime of g of 1 times g of 1. Okay, does that make sense? And then I just need to find that stuff from the table. Okay, so what is g of 1? Well, g of 1 looks like it's 2, right? So that's giving me f prime of 2 times g prime of 1 is 1/9, right? And f prime of 2 then f prime of 2 is what, everybody? -3. So all this stuff just gets replaced with a -3 times a 1/9 is what? -1/3? Okay, good? Make sense? Okay, and then p of x, what does that do differently? So if we want to do p prime of 2, g prime of f of x times f prime of x. It just switched the composition around, so now g becomes the outside function, right? Everybody see that? Do we need to go through that one? Raise your hand if you want to go through the second part. Okay, so we're good. Same thing. Okay? That's it. That's it. Okay, so I will let you have your choice. You can either just work on finishing up assignments, practice test, etc., or you can start your test today. Okay, so if we're coming up with these again, all you do, the tangent line doesn't really make things much tougher at all. You just need the same stuff. You need to be able to find the derivative and evaluate it at -2 to find the slope. Here's a point, and then we just use point slope to come up with the equation of the line. So really the 98% of this problem is just doing the derivative, right? Okay, so let's get one more practice problem on derivatives. So if I want to calculate f prime of x, let's just do this with chain rule, how about? So do chain rule for me. What's that going to give me? Low d high. Okay, so low x squared minus 6 to the fourth. What's d high? Okay, what's next? Minus pi d low. Chain rule. Okay, so what's the derivative? What is d low then? Times. Okay, times. Okay, right, I have to have two links in my chain rule. All divided by low squared. So what would the bottom squared be? There you go. Okay, we just get a power of 8 on the bottom. Okay, so then on this one, all we would do is just clean things up in the top. So 3 x squared times x squared minus 6 to the fourth minus, let's pull the 2x out front, so I'm going to get minus 2x to the fourth times the quantity x squared minus 6 cubed all over, oh, I forgot the 4, didn't I? Yeah. So that would be an 8, not a 2. Okay, so I kind of color-coded this already. We see two different powers that have like bases, agree? Right, so we factor out the least common powers of our like bases. So what's that give us out front? X squared, we can take out an x squared. And what power of x squared minus 6? Third. Leaving behind what from the first term? 3 times x squared minus 6 to what power? The 1. Good. Minus, what's left from our second term? 8x squared. There you go. All divided by, and we'll just pull that out front. And what happens? Yeah, you get a bunch of cancellation. We can cancel 3 of those, leaving 5, product of 5 on the bottom, right? So then we end up with x squared times x squared minus 6 times all that stuff. Now what happens if I distribute the 3 and collect like terms?
Why is there still an x squared minus 6 on top?
Oh, there's not. You're right. There's not. Yeah. That went away, didn't it? That whole thing went away. Yep. Okay, what's left from in here if I distribute the 3 and collect like terms? There you go. And you could pull that 5 out, or the negative out front if you wanted to. That'd be fine. Either that way, or if you wanted to, negative x squared times 5x squared plus 24 over x squared minus 6 to the 5th.
Sure, it's not 24, it's 18.
18?
Yeah, sorry.
Oh, yeah, yeah. Yeah, okay. Yeah, that's better. 18. I was just listening to you. I shouldn't have listened, huh? Okay, good. Makes sense. So there's the derivative. Now we got to do the tangent line. So to find the tangent line, where are we going to evaluate the derivative? -2. Yeah. Okay, so the slope of the tangent line. And honestly, because we were evaluating, really all we needed was the slope of a tangent line, right? Did I even need to simplify this derivative? Not really. I mean, I could have just, if I wanted to, I could have plugged in -2 for x right there. That would have been fine. And just evaluated before I even simplified if I wanted to. I'm going to get the same answer. And then just simplified the fraction. Okay? Okay, but we went through the hassle, so we might as well take advantage of that. So we get f prime of -2 is going to give us the quantity -2 squared times 5 times -2 squared plus 18 over -2 squared minus 6 to the 5th. So what's that give us? 4 times 38. Everybody agree? 4 times 38, so what is that? 76, so 152. No, what am I saying? 76, yeah. 152 over 4 minus 6, that's -2 to the 5th. -2 to the 5th is -32. So we get that. Okay, which is, what could we, I guess we could simplify that and get -76/16. So we could divide by 4, couldn't I? 38/8, so 19/4. So there's the slope of the tangent line. We already have a point, so now we just do point slope, right?
Will there be any chance on the test we don't get the point, like we just get an A and we have to find Y? Or will it give us the point?
I think it'll give you the point. I think it'll give you the point. So y minus -1/2 equals -19/4 times x minus -2. So y plus 1/2 equals -19/4 x minus 19/2. Right? Subtract 1/2 from both sides and get y equals -19/4 x. -19/2 minus another half would be -10, -20/2. So there's my tangent line. That make sense? That make sense, Matthew? Yeah. Okay.
He was too paying attention.
Yeah, he was. Okay, good. All right.